Okay, today I'm going to show you that we can investigate combinations of resistors in series and parallel using a very simple electric circuit. So to start off with, we're going to build a circuit like this. You can see we've got a power source in series with an ammeter, in series with a fixed resistor, which goes back to the power source, and connected in parallel across the resistor, we've got our voltmeter. And from that, we can measure the potential difference across the resistor, and from the ammeter, we can measure the current in the circuit. So, got that circuit built over here. Here is my power supply, here's my ammeter, my resistor is going to go in here, and there's my voltmeter. So let me just get my resistor, place that down here. Okay, I've built that circuit now. So we've got power source in series with the ammeter, which is going to give us a reading in milliamps, in series with our resistor, and connected across that, we've got our voltmeter. So I switch the circuit on, and we get a potential difference of 5.57 volts and a current of 4.60 milliamps. So we get 5.57 volts and a current of 4.60 milliamps. Now, that's a little bit concerning, because in order for us to calculate the resistance of our resistor, we would need to do the potential difference divided by the current in amps. So we need to convert this into amps by dividing by 1,000. So that's 0.0046 amps. So then we are left with 5.57 volts divided by 0.0046 amps. Let's go and work out what that is. So we've got 5.56 divided by 0.0046. Oh no, sorry, it was 5.57. So there we go. And then we get something close to 1,200 ohms. So this is roughly 1,200 ohms. So this resistor has a resistance of about 1,200 ohms. So what happens if we put two of those resistors in series with each other? Because now we've got our power supply here in series with the ammeter, in series with this resistor, and in series with this resistor, and we've got our voltmeter measuring the potential difference across it. How might that change things? What now is the total resistance in here? Well, we can work it out, because, switch off my power pack, instead of having this single resistor in here, we can put in this, which is two of those connected in series. So I've connected that now. It's exactly the same circuit as before, power pack, ammeter measuring milliamps, with these two resistors in series with each other, and the voltmeter measuring the total potential difference across. Switch my circuit on, and you can see we've got 5.65 volts, and we've got 2.32 milliamps. So 5.65 volts, and our current 2.32 milliamps. Now, just like before, in order for us to calculate the total resistance of these two resistors together, we need to do potential difference divided by current, but the potential difference needs to be in volts, which it already is. The current needs to be in amps, which it isn't. So we need to divide this by 1,000 to convert it into amps, 0.00232 amps, and then our equation for resistance becomes 5.65 divided by 0.00232, and that will give us our total resistance. So we've got 5.65 divided by 0.00232, and that gives us a resistance of about 2,400 ohms. So if we compare, when we had this single resistor, it was 1,200 ohms. And when we've got the two resistors in series, it's 2,400 ohms. It doubles. Fairly straightforward. But what about if we arrange the resistors like this? What if we have these two resistors in parallel with each other? Might be worth considering what's going to happen. We had 1,200 ohms like that. we had 2,400 ohms like that. When we arrange them in parallel like this, what is our total resistance going to be? Well, we can calculate it because, switch the circuit off, instead of having these two resistors in series, I can replace them with here. I've arranged two of the same resistors in parallel. So I can clip that on there, and I can clip that on there. And now we have exactly the same circuit as before, except this time we've got two resistors in parallel. So we've got that circuit set up. So I can switch it on and I can measure. We get a potential difference of 5.50 volts, and we get a current of 9.05 milliamps. So 5.50 volts and 9.05 milliamps. Now, just like before, we need to convert this into amps by dividing by 1,000. So that'll be 0.00905 amps. And now we can use our resistance equation, potential difference divided by resistance. So that's going to be 5.50 divided by 0.00905. We run that through our calculator. So it is 5.50 divided by 0.00905 amps. Press equals and we get about 600 ohms. So when we have the resistors like this, it's only 600 ohms. Two resistors in parallel, and we get half the resistance we had like this. And that is the second part of required practical activity 3.